Well, welcome back, ladies and gentlemen, boys and girls. Did you all have an excellent time at the career fair? Are you all now on the path to become gainfully employed over the summer? Good, glad to hear it. Well, I'm assuming that because you're a third of the way through the time allotted for your SolidWorks project, that you're a third of the way done already, right? Of course. You wouldn't wait until the Thursday before it's due to start it. That's due 2 weeks from today, question mark. For full due date information, see the D2L calendar. Speaking of which, we find ourselves on Excel Day 1. So, like I had said on Day 1, the plan is to talk about a couple of different software packages in this class, and the intention is not necessarily for everyone to get 10 units of experience better. It's to make sure that if you guys come in with a certain amount of experience, that some of you probably know a lot about Excel. Many of you probably know a little bit about Excel. There's maybe only one or two of you that know very little about Excel. But the goal isn't to make sure that everyone goes up by 20 units of experience. The goal is to make sure that everyone is at some minimum threshold level so that you can be expected to use that in future classes. For SolidWorks, I'm guessing a couple of you, maybe 20–25% of you had used a 3D modeling program before. With Excel, I'm guessing it's more like 60 to 70%. For MATLAB, it's maybe going to be 5%, maybe 2 or 3%. Whatever amount of you have done calculations in Python, it's probably as close as you've gotten before. So that one's probably going to be a lot more new content. But over the course of the next 5 days, we're going to start with the bare basics. We're going to work slowly up through the basic fundamentals. Once we get past a certain threshold of fundamentals, we'll pick up some speed, and I'm guessing that around about Day 2 or 3, we will hit a point at which most of you are learning new stuff. Does that make sense? Okay. So, like with SolidWorks, I'm going to err on the side of caution on Day 1, so we're going to start with the basics. Before I get too wrapped up in my Excel momentum, though, any questions on SolidWorks projects? Have you all picked a thing? Are they good things? Cool. Glad to hear it. Anyway, within Excel, you are able to perform calculations, and most of those calculations are built around a matrix. Like with MATLAB, MATLAB after all stands for Matrix Lab. Excel is built around matrices, and Excel is like every single work computer on the face of the planet has Excel installed. So when it comes to performing calculations in such a way that you can pass off your software reasonably to someone else with the expectation that they can open it and use it, Excel is like the #1 useful tool for that. One of my jobs that I had after I graduated, before I started teaching, was going around to businesses and performing energy audits, going to farms and doing energy audits, going to residences and doing energy audits. That entire job involved holding an iPad and filling in cells on an Excel calculation sheet. We had built the sheet so that everyone did the same thing and we tabulated the data in the same way. My internship between my junior and senior year had all of its calculations done in Excel spreadsheets. Excel, super underrated tool, and it's useful to have the basics. So, when you open up Excel and create a new file, what you're doing is creating what Excel calls a workbook. A workbook is an Excel file that contains multiple worksheets. Those worksheets, or sheets for short, are referenced by these tabs at the bottom. Each sheet contains a blank matrix that has a number of cells, and depending on if you're running the 32 or 64-bit version of the software, that is either an unreasonable amount of cells or a super unreasonable amount of cells. It is unlikely that you are ever going to use all of the cells in your worksheet, except for possibly on Day 4 when we do an unreasonable example problem. Hashtag foreshadowing. In the meantime, for the most part, you're going to be picking off some amount of cells and typing in numbers or performing calculations or having some sort of formatting so that you can see stuff. Within cells in Excel, if you type in letters or numbers, they appear. Cells are identified by a designation by default That is a combination of the letter that identifies the column and the number that identifies the row. Note that in the upper left-hand corner, we start with cell A1. And as we go to the right, we are incrementing the column. Once we run out of letters, we just add more letters. So we go P, Q, R, S, T, U, V, W, X, Y, and Z. And then we go A, and then AB, and then AK, and then AD, and then A, and then AF, and so on. We can keep going to the right and add even 3 letters if we go over far enough. Within row numbers, conveniently, we have a nice decimal system where as we run out of digits, we just add another digit out front, and we don't have any fun ways to pronounce those sequence of digits other than their names. So, for example, we have 35. And scroll down, you might even encounter 135. And if you scroll down even further, you might encounter 1035. Cells are identified by default by the combination of their column and their row. So I could say, here in cell F3, I'm going to type a number. Like, let's say I wanted to type the number 4. And then I can move down and type the number, 6, and then possibly even 78. And I could identify these as like some sort of table value. Maybe I'm saying number, let's go with number of energy drinks drank. And then number of exams graded, and number of exams to grade. I gave a fluids exam last Friday, so exam grading is on my mind. I could identify this as a reference to that specific label if I wanted to as well, and I could even format these into a thing, a number, make it all pretty like. I could say, hey you, table, I want you to be formatted like a table in Word, and I want you to have some sort of indication on the top of what is the label, and I want these to be bold, and I want them to have decimal places, and I want these up here to be an entirely different font. Let's go with Calibri Light, because light obviously is going to indicate that that is a header, and I want all of this to be white, and I want this to be, surrounded by some sort of extra lines to make it look all fancy, and maybe I'll even make the middle one a nice light gray color. We've made a pretty table. We can do all sorts of stuff to make pretty tables in Excel, but for the most part, in the field of engineering, we don't care about making pretty tables. Instead, what we want to do is perform calculations. If I ever get frustrated with one of these sheets and I want to start over, I can just create a new sheet by clicking on this plus button down here next to the sheet identifiers. So I could say, let's create sheet 3, and this time, maybe let's do some math. So I will generate some more numbers, like, for example, the number 6, and the number 7, and the number 8. And let's say that I wanted to take this column and perform a complex calculation on it, like maybe even adding 2 to each of the numbers, right? How many times have you been in the situation where you had to add 2 to a number, and you had to break out the calculator, you had to fire up your TI Nspire to be able to calculate a number as the result of adding 2 to it? Well, I can do that within Excel by saying, take the number in that cell and add 2 to it. To do that, I'm creating a formula. Formulas in Excel are entered into the formula bar at the top. So if you're familiar with Microsoft Office products, the tabs at the top here contain a variety of information useful for things like formatting, useful for things like referencing specific types of data, or trying to indicate how you want it to appear. But what we want is below that. Below the header, we have the function bar, also known as the formula bar. In the formula bar, we can type formulas. And I can reference cells with their identifier. So I could say, in C2, maybe I want to take the value of cell B2 and add 2. To perform a calculation, I can reference a cell using its designation and then perform a calculation around it. To indicate to Excel that I want it to perform a calculation as opposed to just literally make, quote, B2 plus 2, unquote, appear, I add an equal sign to the beginning. So equals B2 plus 2 tells Excel, treat it like a formula, and now it has taken the cell B2 and it has added 2 to it. It's storing the result and also displaying it to us. Depending on our circumstances, we may want it to change how it stores it or how it appears. For example, if this was a slightly more complicated calculation, maybe even, let's say B2 plus 2.1, or maybe 2.15, And I said, Excel, I know that that's 8.15. You know that that's 8.15, but I don't want to confuse the reader. Let's round that a little bit. I can indicate to Excel that it should round by decreasing how many decimal places to show. And that's changing how it's appearing in the table, but it's not changing how Excel is storing it. So behind the scenes, it's still stored as 8.15. And I can do more calculations with it. Like I could say over here in E2, I could say take the value of C2 and add 2 to that again. It'll appear as 10.2, but if I add decimal places to it, it's still using 8.15 behind the scenes. Same page so far. Addition is not the only calculation that I can perform. I could even perform like subtraction, or multiplication, or division. All of those appear as the symbols that are associated with the numpad on the computer. For those of you that are using laptops that don't have numpads, it's the plus, the minus, the asterisk, and I believe that's a forward slash? Question mark? I don't actually know what the difference between a forward slash and a backslash is. I've been told it's like if you imagine a person that's walking across the line and they're leaning forward or leaning back, that's the indication of the slash being a forward slash or a backslash, but I never remember which way they're supposed to be walking, so I don't know. It's the slash that works and it's not the slash that doesn't work. In addition to these basic arithmetic calculations, we can also call special functions. Like, for example, let's say that I wanted to perform a calculation that took B2 and B3 and B4 and averaged them together. Well, over here I could say is equal to parentheses B2 plus B3 plus B4 end parentheses divided by 3, and I have done the arithmetic to average them together. But there's a special function for that as well. It's called average. When I call the average function, I can just type in B2, comma, B3, comma, B4. When I call the function, it figures out how many of the quantity there are. It adds them together and divides by that number of quantity. If you're curious as to how I knew that there was an average function, I can see how many functions there are and how they are available and how they're used, the arguments that are involved with them, by clicking this button here, Insert Function. Insert Function brings up a dialog where Excel will be like, hey, what are you trying to do? I got you. For example, if I get rid of this, I could say, Excel, I want to do an average of some sort. Help me do averages. Well, type a brief description of what you want and then hit go. Nope, got to delete it. I want to do averages. Go. Well, it says, here are a bunch of functions that might be relevant to what you're trying to do. So I could say, maybe I'll just type the word average. Hey, there's an average function. Neat. The average function returns the average, the arithmetic mean, of its arguments, which can be numbers or names, arrays, or references that contain numbers. Don't worry, we'll talk a lot more about functions. In the meantime, though, you may have noticed that I said average B2, comma, B3, comma, B4, close parentheses. By indicating all of those separate values with commas between them, I'm using an array as an argument. So I'm creating a little mini array storing the values B2, B3, and B4 and handing them off to Excel. It's performing the calculation with them. That is one way of identifying a number of cells together, what Excel calls a range. So just like how cells are identified with the combination of the column letter and the row number, ranges are indicated using the starting column, end column, starting number, end number. For example, the range G4 through J11 indicates this block of cells here. Instead of indicating B2, comma, B3, comma, B4, I could just give it B2 through B4. The colon indicates to Excel that I want to establish a range. So instead of saying B2, comma, B3, comma, B4, I'm saying B2, colon, B4. I don't know why that projector keeps going off and on. I will give it my most withering stare. See if that fixes things. Does that make sense? Ranges can be two-dimensional, they can be one-dimensional, they can even be three-dimensional. Next up, if the cell identification by column and row is insufficient for your purposes, you can also reference an entire column or an entire row. For example, instead of saying the average of B2 through B4, I could actually just say, hey Excel, grab these cells, build a range for me, and dump them in. The average function will ignore cells that have empty values, so it still returns a 7 to me. Or I could go one step further, and instead of saying B2 through B19, I could just say, hey, Excel, grab the entire column B. All of it, the whole thing, and average that whole thing together. Now, regardless of where numbers are, like 9 or 10 or 11 or 12, I could scroll way down here to like B400, and I could put in 9. And look at that. I still have the average. How neat is that? In addition to referencing a range with a selection or as an entire column, I can also name them. So let's say I wanted to perform a calculation where I had, I don't know, x values and y values. So maybe an x value of 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. And I wanted Excel to calculate y is equal to mx plus b. So I might establish like an m value and a b value, and since they're going to be used multiple times, I can treat them as variables in Excel by putting them in their own separate cell. So I could say something like 12. Slope of the line is 12, and the y-intersect is 5. Now, in Excel, I'm going to say is equal to b3 times g2 plus g3. So Excel is going to take 1 times 12 plus 5 and return 17. But G2 and G3 are real arbitrary. If you're trying to make this easy to read, especially if you have complicated calculations, or better yet, if you're giving it to someone else and getting them to try to read your complicated calculations, G2 and G3 might not be sufficient for your purposes. You can actually name cells something that you specify. So for example, instead of G2, I can give this a name by going up into the name box and typing something. So I could say slope, for example. And now the cell G2 can be referenced with its identification G2 and also as this new identification slope. Similarly, I could define G3 as being B. B by itself is already used because that's the column B. So I can make it something else like B. Now I have slope and B. So back over here I can say B3 times slope plus B. I still get 17. How neat is that? It's pretty neat. Questions so far?
Can you do multiple slopes at the same time?
I can't have another cell with the same name. So over here, if I said other M 13, and I tried to name this cell slope as well, Excel will say, can't do that. Slope's already been claimed.
And then, like, can you do like the entire row of B's in the formula at the same time?
An entire row of B's? Or are you saying do this calculation multiple times?
Yeah, do the calculation multiple times.
Interestingly, that's about exactly what I was going to prompt you with. That is what I want to do next. Great minds think alike, I've always said. Now, we did one calculation. We did B3 times slope plus B. Well, I could copy and paste this into cell C4, and I could say, hey, take B4 times slope plus B. Or I can also tell Excel to take a formula and try to extrapolate it. So apply it to multiple cells. To do that, I can copy it and paste it by right-clicking and going into Paste Formulas, or I can also just grab this little indicator in the bottom right and drag down. So when I drag down, Excel is going to populate that function. And to explain how this works, I need to introduce another concept called relative versus absolute references. In Excel, B3 is a relative reference. So it's not actually treating it as B3. It's treating it as the cell that is 1 to the left of your current position. Now, when I'm propagating that function down, it's continuing to use the cell that is to the left of your current position. So if I go back to, say, G3, or G2 and G3 here, instead of slope and B, like this, and drag this down, my calculation will break. And the reason it breaks is because these relative references are being propagated down. So now instead of G2 and G3, it's G3 and G4. That's no longer slope and B. This is G4 and G5. That's something else entirely. Relative references automatically propagate when you click and drag or when you copy and paste functions. If I want to switch a relative reference to an absolute reference, I can identify cells or ranges by name, like we already did. Or I can switch a reference to being absolute by introducing a $sign. $sign in front of the designator switches it from a relative reference to an absolute reference. So here, if I say B3 times $G, $2 plus $G, $3. Now G2 and G3 are an absolute reference. So when I propagate this function down, it propagates with it as an absolute reference. It doesn't change. The reason I have to add a $sign before the column and before the row is because there might be situations where I want the column to be absolute, but not the row. So the first example that springs to mind is, what if I wanted to make a multiplication table? So I find myself in these situations all the time where I have to multiply numbers together. And that's awfully embarrassing when I'm in front of a classroom, say thermo, and I'm trying to multiply numbers, and we say, like, what's 3 times 5? I'm not Bill Bloxam. I can't do that math in my head. So I have to get out my fingers and try to keep track of them. If I could come up with a solution, maybe something that I could adhere to the wall that had all those calculations done for me, then I wouldn't need those anymore. So let's say I wanted to pre-populate all the values of 1 through 10 multiplied by 1 through 10. Well, I can have Excel do that math for me. It's withering stare time. See, fixed it. So what I'm going to do here is indicate to my own eyes that I want these to be headers. And then I'm going to change the formatting a little bit by changing the width of these cells to make them a little bit more square-like so that my multiplication table looks a little bit more square-like. And I'm even going to go one step further, and I'm going to add fancy borders to make this a little bit more clear. Something like that. So if you didn't follow what I was doing, I resized the columns by grabbing onto the line at the side of the column and sliding it around. You can resize multiple columns at once by highlighting them, changing the size of one, and all of them will follow suit. In the event that you want to be more precise than just clicking and dragging, you can also right-click column width and change it to a number of your choice. Like, for example, the number 4. Now there are all 4 units of width. Okay, so in cell C3, I want to type a function that performs my math for me. I want it to take the cell that is above me and the cell that is to the left of me and multiply them together. So I could say equals C2 times B3. And when I hit enter, I get the result. 1 times 1 is 1. Yes, so that makes sense. It is accurate so far. And then I can click and drag to the right to propagate that function. Oh no. 1 times 1 is 1, 2 times 1 is 2, but 3 times 1 is not 6. This is breaking because it's continuing to use a relative reference. So it's saying cell to the top of me multiplied by cell to the left of me. So that is no longer what I want. I have to switch this from a relative reference to an absolute reference. But note, if I switch them to absolute entirely, like this, and drag that to the right, that also isn't what I want. I don't want to just take the cells C2 and B3 and multiply them together over and over and over again. I want it to propagate in one direction but not the other. So I can go up here and I can make one of them absolute in one way and the other absolute in the other way. So how about I pose that question to y'all? Which one is which? Where do I add the dollar signs? Sorry, what?
Would you add the B on the dollar sign? Just them?
So if I added the dollar sign in front of the B, you're saying?
Yeah,
And the 3, like this? Well, that would work for the first row, but I also want the ability to propagate this down. So,
C?
well,
Would you have a dollar sign in front of C too?
so if I did this,
Yeah.
is that what you're saying?
No, change it back to what, yeah, like that.
Okay. This still isn't going to work.
Without the dollar sign in front of it.
I have to get rid of one of the dollar signs. Which one is it? Well, let's try the one before the 3. Now it's C2 times B3. Drag it to the right. Drag it down. We're close, though. It definitely involves 2 dollar signs.
I just switched the 1 on the C to the 2 instead of C dollar sign.
So we switched the dollar sign to being in front of the row designator on the first one and the column designator on the other. Are you following that logic? Okay, I'll pause here for a second while you guys look at that and go, wow, that's incredibly impressive, and we're only 20 minutes into day 1. Okay, by the way, while we're here, pro tip, when you want to add dollar signs, you can type in dollar signs like some sort of peasant. But there's also a faster way. There's a special shortcut. It's F4, in fact. So if I get rid of my dollar signs here, and I click on this and I hit F4, it toggles between fully absolute, row absolute, column absolute, relative. That's way faster, right? Cool. While we're here, within this little example, it also might be helpful for us to talk about something else that you can do with propagation. Like, you saw earlier when I typed 1, and then I typed 2, and then I typed 3, and then I typed 4, and then I typed 5, and then I typed 6, and then I typed 7, and then I typed 8, and then I typed 9, and then I typed 10. That works just fine for this 10 by 10 multiplication table. But keep in mind, we want Excel to do as many of the calculations for us. We want it to keep track of what we actually want. We don't want to do stuff by hand. If we were making a multiplication table that was like 100 cells by 100 cells, that would be a little bit monotonous for us, right? I mean, we're engineers. We can make the intern do that. Or we could build a system that does it for us. So instead, I could actually just go into cell D2, and I could say equals C2 plus 1. Relative reference will grab the cell to the left and add 1 to it, and I could drag this over as far as I want it. Neat, right? And in fact, I don't even have to use a formula for that. When you propagate, using that little button in the bottom right, Excel will try to predict patterns. So here, if I highlight 1 and 2 and drag to the right, okay, that's a great example. If I grab just 2 and drag it to the right, Excel's figured out the pattern and is continuing it. But as we noticed when we highlighted both of them, it's by no means perfect. So like I could just type 2, drag it to the right, and over here, I could probably even just do it with 1, and Excel will probably assume that I want to increment by, nope. Okay, 1 and then 2 to establish the line, takes 2 data points to establish, that's not right. 1 and 2 maybe, oh, see, that's much more better. You kind of have to work with Excel to make it work. Like it even does that with like Monday, Tuesday. Excel, figure out what I want to do. Wednesday, well done. Thursday, well done. Friday, Saturday, Sunday. Rebecca Black would be proud. We made it all the way through. But that doesn't work all the time. Like I could say January, and I could say Excel, drag that down. Great, works. What about like if I made a mistake? February. I wonder how that's going to work. January, February, March, February, April, February. Well done, Excel. You're so great at things. So the whole trying to get Excel to guess what you're doing and propagate it is kind of finicky. So I'm generally in favor of, hey, just make a function and propagate the function as opposed to trying to use the absolute values of the cells. Same page so far. It's the old knuckle method. You count your way across with the months. It goes January, and then February, and then February, and then February, and then March, and then February, and then April, and then February. It's like a reverse leap year. So what I want to do next is try an example here. And this example is going to revolve around some data that exists in a data file. So what I want you to do is go into D2L's content, go to in-class resources, and I want you to download the file that says dummy grades Excel day 1. So I'm going to download that file. So I have downloaded a file. It is called dummy grades Excel day 1. This file is a CSV file. CSV is short for comma separated values. When you are exporting data from something, like maybe a piece of test equipment or from a database, you have these system agnostic file formats that can store data without being specially an Excel file or a MATLAB file or whatever. Those system agnostic file formats are generally just different ways of storing text and telling the computer how to differentiate between columns and rows. So like if I right click on this and open it with, I don't know, Notepad or something, I can see how it's actually stored. We have student ID, name, homework 1, etc. Columns are differentiated by return. Rows are differentiated by commas. That's why it's called a comma separated value, CSV file. I can open up a CSV file in Excel, but Excel is opening that as a CSV file. We're looking at it as a CSV file. If I want to actually do calculations on it and save those calculations and do special formatting and stuff like that, I have to format it as an Excel file and save it as an Excel file. So we could open the CSV file, save it as an Excel workbook file, but the better way to do it, best practice here, is to import the data. So what you want to do is go up to Data, Get External Data from Text. So I'll pause for a second. When you want to import data into an Excel worksheet, what you want to do is go to the Data tab, go to Get External Data from Text. This is Excel 2016. That happens to be what's pre-installed on the Potato. If you guys have Excel 365, which I believe you guys do with your student access, I think that you have a newer version of Excel, and as a result, your data button looks a little different. I believe that you just have like one file that says Get External Data. You taking a picture of it?
No.
That's,
I'm waiting for George Orwell.
oh, we'll get to that in a second. There's going to be a lot of pop culture references. It's fine. Patience. You've got this. Have you found the data button? Woo! Okay, so we're get external data from text, and now Excel is going to walk us through a wizard. And the wizard is going to help us import our data. So we're going to go up to Downloads, because that's where our CSV file is. We're going to click on CSV. We're going to hit Import. Now Excel is going to ask us some questions. First up, is your data file delimited? Which means, is there something separating your individual columns, or is it a fixed width? Referring to, are there a certain number of characters that represent a column, and each set of characters is a different column? Ours is delimited. It is delimited by a comma. Thus, CSV file. So, delimited is what we want. Step 2, where's the file from? Is it from the United States? Is it a different ISO format? You can pretty much ignore that for all of our purposes because they all come from my computer, which is within the United States and uses the ISO standard. Next up, my data has headers. That's asking us if we should treat the first row as data or as headers for the data. In this case, I can see visually that the first row contains column identification. So I'm going to click the My Data Has Headers checkbox. Now I'm going to hit Next. It's going to say, neat, you have a delimited file. What is it that delimitates each character that was column from each other column? The thing that delimitates each column is a comma. Thus, it's called a comma separated value table. So I'm going to click on comma, and at that point, I'm done. I could click Next again. It's going to say, how do you want to format these? Do you want these to be numbers? Do you want them to be dates, and so on and so forth? I can say, no, that's fine. Just leave it, and hit Finish. Now it's going to ask me, where are you wanting us to put that? Do you want to put it in this worksheet? By default, it'll use wherever your cursor is. So my cursor right now is in cell A1, so it's going to start the table import with the upper left-hand corner in cell A1. That happens to work just fine for what we're doing. I could also add it to a worksheet. Let's just make a new worksheet that is only this table. That's fine too. But existing worksheet works well enough for our purposes. Poof, we've inserted the table. If you want to Snapchat the table, now's your chance. Okay. I can even zoom in for you.
Did you make this yourself?
I did.
You like George Orwell?
It seems, culturally significant right now. You can see that I'm not good at making up numbers either.
No.
So I could only come up with 5 students. We have 5 students. Each student has a student ID number. They have a name. They have 5 homework scores, each of which is evaluated out of 10. They have 3 quizzes, each of which is evaluated out of 50. They have 3 exams, each of which is evaluated out of 100. For the purposes of this example, let's say that I want to calculate some grades. And I'm going to calculate their current grade in the class based on this breakdown. So homework, forgot how to spell the word homework for a second. You can tell I've been grading too long. Homework, quizzes, exams, final exam. So let's say their exams are worth 50% of their overall grade, their final exam is 25%, quizzes are worth 15%, and homework is worth 10%. Sort of rubric that you might find on a syllabus for, say, Thermo 1. I'm using the information we have in this data to calculate a homework subtotal, a quiz subtotal, an exam subtotal, and also a current grade in the class. The first step would be optional. One of my options would be to designate this as a special type of range. That special type of range is called a table. To format this as a table, what I'm going to do is click on Home and then click on Format as a Table. Formatting this as a table gives us some formatting options for it and also identifies some special things about it. So for example, if I click on one of these random formats, I say my table has headers, so it's going to use the first row as headers. It's also going to say, hey, you got this data from an external source. Do you want me to break the link to the external source? I say, yeah, it's fine, Excel. Now I've formatted this as a table, which has special characteristics. For example, I can sort things. I could say I want you to sort by student name, or sort by student ID, or sort by exam 3, from largest to smallest. I could say I only want to show people who got a 10 on homework 5. Tables have special powers. The convenience of sorting, the convenience of formatting as a table is mostly when you create a calculation, it automatically propagates to the rest of the rows. You can also identify columns because all of the columns already have names associated with them. So let's say I'm going to calculate a homework subtotal, which I'm going to call HW sub, a quiz subtotal, which I'm going to call Q sub, an exam subtotal, which I'm going to call E sub, and then a current grade, which I will call grade. You'll notice when I added a column header to the right of the table, Excel grouped that in, like Manifest Destiny style, into my table. Just added an extra column into the table. And like I said, the advantage of this is when you type a calculation into one of the rows, it automatically propagates through the rest of the table. And you can reference columns by name. Like let's say I wanted to say, hey, what is the average of exam 1? 69.5. We can reference the range, all of the data within exam 1, by calling it by name. This table was defaulted to a name of table 1. I could change that though. I could say, I don't know, student grades. And now it's designated as student grades column E1. Does that make sense? Tables are neat. Anyway, my homework subtotal is going to be the average of these 5 columns together for an individual student. So I could say C2, C3, C2, D2, E2, F2, G2, I could use the range identifier, which would be C2 colon G2, or I can actually just grab them, click and drag. Excel is going to use this identification metric, which only applies within tables of square bracket, to say, for this student, grab everything between homework 1 and homework 5. Again, tables have special powers. So I'm going to take the average of those 5 values. I'm going to divide that average by 10. That gives me their homework subtotal. Right now it's expressed as a decimal. I can switch it to a percentage by highlighting all of them, clicking on the percentage number, and then maybe adding a decimal place. Neat. Similarly, for quizzes, I could say equals average. Quizzes 1 through 3, close parenthesis, divided by 50. Exam subtotal equals average. Exams 1 through 3, close parenthesis, divided by 100. Make these all be percentages with a decimal place. Same page so far. Okay. How do I calculate a grade using these subtotal values and those weightings? I'm going to multiply the weight by the subtotal score. So for each student, it's going to be equals. And then I'm going to say homework subtotal times 0.1 plus quiz subtotal times 0.15 plus exam subtotal times 0.5. Close parenthesis. Is that it? I have to do one more thing. We're calculating a current grade, and the final exam hasn't been included in the table yet. So in order to evaluate this out of 75% of the available points, I have to divide by 0.75. Does that make sense? Okay. Cool. So I can see highest score in the class is an 85%. This really must be a Thermo 1 class. Questions so far? Okay, cool. Well, just as a fun additional exercise here, what if in addition to their current grade, I wanted Excel to figure out what letter they should get? That'd be a fun challenge, right? I mean, let's add a column for that. Let's call it letter. I like it. So what I want to do is have Excel calculate something based on logic. And I have a couple of different types of logical functions. The first one that we're going to talk about is if. If is an if-then-else statement. If you want more information about the if function, you can click on Insert Function. I can type in if, hit go, and Excel will say, hey, here's all the information about the if function. So if takes 3 arguments. The first argument is the thing to test. The second argument is what to return if true. The third argument is what to return if false. So I could say equals if grade greater than or equal to 0.9. If grade is greater than or equal to 0.9, output A. If not, output not A. Close parenthesis. Now when I hit enter, it's going to perform that evaluation for all 5 students. Now unfortunately, that's not quite sufficient because there are more letter grades than A's. I mean, you guys wouldn't know that because I'm sure you've never received one. But there exist other letter grades as well. So for example, another one of the letter grades is B. And B is identified as any grade between 0.8 and 0.9. 80 and 90%, right? So what I'm going to do here is I'm going to nest an if statement within another if statement. Are you ready for this? Okay. So if grade greater than or equal to 0.9. If true, output A. If not true, evaluate if grade is greater than or equal to 0.8. If so, output B. If not, not A nor B. So that second if statement was in the false statement of the first if statement. Does that logic make sense? So now when I hit A, we have a couple B's and a couple not A nor B's. So, in addition to A and B, there's also a C grade. And a C grade is anything between 0.7 and 0.8. Because if grade greater than or equal to 0.7, output C. And while we're here, I mean, let's just add another one. Like, for example, if grade is greater than or equal to 0.6, output D. And if it makes it through all 4 of these logical statements and it hasn't returned true, that must be a failing grade. Now I need to close the 4th if statement, and then the 3rd, and then the 2nd, and then the 1st if statement. I don't know if you guys can see it on the projectors, but the parentheses actually appear as color code. So like the first one on my screen appears as just a little bit green. The next one is just a little bit purple. The next one's a little bit red. The next one's black. So that helps me keep track of where I am. So now I have an error. I failed on the failure grade. That's fun. So now I have a letter grade that's automatically calculated. So like if this student actually got a 98 on their first exam, look, they went up to a B and it automatically switched to a B. That's convenient, right? The other advantage of this is because I'm calculating the homework average by using the average function, it automatically figures out how many things there should be. So I can have like a homework 6 and a homework 5. And it automatically includes that. I guess 98 is a little bit extreme. They have 231.7. Well, I mean, I would expect nothing less from Matthew Archimedes. So 9.8, and then like 7.2, and then Chris Dodd, I mean, his Irishness has got to give him at least 9.9. And then 5 and 6. I like it. Questions? Okay. We started at nothing. Like Jon Snow. We introduced a couple of basics in formatting and referencing cells. We introduced functions. We introduced ranges. We introduced tables. We imported data. We performed some calculations. That's day 1. On day 2, we'll start other ways of referencing data on multiple sheets at once. And for that, I'll see you guys on Tuesday. Your first homework assignment is assigned today. It's on D2L. It's basically just the same examples that we reference here. And then that will be due next Thursday.
Like a weightlifting rack, you know, kind of complex.
As long as it comes with 5 legs. Yeah, worst case scenario, you could do it hidden. 1 and 2, just like or that, or yeah, maybe like a 45 plate and a 25 plate, a 10 plate and a 5 plate. Yeah, it's fine.
Alright, so for my final project thing.
It occurs to me that I should stop the stream before we start talking about stuff. I don't want your question to be broadcasted to the entire internet.